In today's video, we'll be talking about design of reinforced concrete beams, how we are going to design it with the steps. Let's look into the steps on how we are going to design a singly reinforced beam. First, we write the given details. When a question is given to us, we write the given details. Step 2, we calculate the effective depth for simply supported beam L by D less than 20. It has to be in the range L by 12 to L by 15. For cantilever beam, L by D less than 7. For continuous beam, L by D less than 26. These are the formulae that you have to keep in mind when calculating the effective depth. Okay, we calculate the effective width. B by D is equal to 1 by 3 to 1 by 2. That is, effective width value has to be D by 3 to D by 2. Calculation of effective span is the next one. That is L effective, clear span plus depth or clear span plus width of support. When we take the minimum value, calculation of ultimate load, TL is equal to DL plus LL, total load, that is dead load plus live load. Dead load is the self weight. Sometimes flow finish load is given to us, so we have to add that with the dead load plus live load. Usually we'll be using dead load plus live load. Dead load is the self weight, rho into B into D. Overall depth is calculated by effective depth plus the effective cover. Effective cover will be given in the code, or we can assume any value of the effective cover which is given in the code. We calculate the ultimate load W, total load into FOS, that is factor of safety. After that, we calculate MU and MU limit. Here, MU is equal to WL square by 8, where L is L effective and W is ultimate load. Why we are using this formula for MU? It's because with under reinforced what type of section it is, it's not mentioned. So the load is distributed here, so we take this formula. Now let's calculate MU limit. Okay, so we find the value of MU limit with this formula: 0.148 Fe250, Fe4 15.133, and for Fe 500.133. If MU less than MU limit, no need to redesign it. But when if MU is greater than MU limit, the structure has to be redesigned. Here, how we redesign is that we just have to increase the depth value. Step 7, now we calculate the area of steel. We use this formula since MU less than MU limit is an under reinforced section, no need to redesign, so we use the formula of moment of resistance in this case. We get the required area. Number of bars is equal to AST required by area of 1 bar. Here is the area that the moment of resistance will act upon, but we have to find the provided area, that is the how much the area that the bars acquire. Now AC provided is equal to number of bars into area of 1 bar. Next we do the design of shear. We find the ultimate shear force, then we find the shear stress value, then we find the shear stress of concrete, then we find the maximum shear stress the concrete can withstand. If it satisfies the condition tau V less than tau C less than tau C max, we do not have to provide additional shear reinforcement. Otherwise we have to, and we also have to find the by finding, first we have to find the shear reinforcement of the shear force of the shear reinforcement, and then the then it's the same, find the spacing and the maximum spacing. Next we find the minimum spacing and minimum reinforcement, that is we check the using the spacing formula that I mentioned in my previous video, and we take the minimum value with the max also by finding the maximum spacing. Then we find the minimum reinforcement, that is the area of the this, vertical slabs provided, ASV. We already have the value of ASV. Also we have to check the ASV provided, and if it's in the range, it is safe. After that we calculate the maximum and minimum area. Maximum area is equal to AST by BD. Minimum area is equal to 0.04 B into overall depth. Then if AST minimum less than AST provided less than AST max, the condition is satisfied, hence it is safe. After that we check for deflection, that is for simply supported beam L by D less than 20 into modification factor. For cantilever beams L by D less than 7 into modification factor. For continuous beams L by D less than 26 into modification factor, we can find the modification factor using the code, and if it is satisfied, the structure is safe. Then we check for development length so that we can provide so that steel reinforcement can be at its full strength. LD is equal to 0.87 Fy 5 by 4 tau BD, where tau BD is the nominal shear stress. It is given in the code. Then we do the detailing part. This is how the detailing part looks like. I hope you understood today's video. So when we give a question is given to us, how we design a beam, what all we have to calculate: depth, width, area of steel, stresses, forces, development lengths, etc., minimum spacing, area. So that's how you calculate when a question is given to us. I hope you understood today's video. So with this I'm going to conclude. Thank you.